Aircraft structures exist to guide forces safely, not to simply resist them. Every force acting on an aircraft, whether from the air, the ground, or internal systems, must travel through a defined load path made up of skins, spars, frames, stiffeners, and joints. Loads never disappear. They flow continuously through the structure until they are balanced by opposing forces or safely absorbed. 4 fundamental forces act on an aircraft during flight. Lift, generated mainly by the wings, acts upward. Weight, due to gravity, acts downward through the aircraft mass. Thrust, produced by the engines, pushes the aircraft forward. Drag, caused by aerodynamic resistance, acts opposite to motion. These forces create aerodynamic loads that vary continuously with speed, angle of attack, maneuvering, and turbulence. Wings, tail surfaces, and control surfaces are primarily designed around these aerodynamic loads, which form the baseline design loads for aircraft structures. Lift does not act at a single point. It is distributed over the wing surface. The wing skin first picks up the aerodynamic pressure, then transfers it into ribs, which distribute loads chordwise, spars, which carry bending and shear loads, wing box, the primary structural beam of the wing. From the wing box, lift flows into the wing root fittings and then into the fuselage frames and keel structure. This path allows the fuselage to carry the wing loads and balance them against weight and inertia. As loads travel through the structure, they generate different internal effects. Tensile loads occur when components are pulled or stretched. Lower wing skin and lower spar caps are in tension during normal flight. Fuselage skin and stringers experience tension due to pressurization. Control cables and tie rods primarily carry tensile loads. Compressive loads occur when components are pushed or shortened. Upper wing skin and upper spar caps experience compression. Frames, bulkheads, struts, and landing gear members resist compression and buckling. Shear loads occur when forces act parallel to a surface, dominant in wing webs, fuselage skins, ribs, frames, and fasteners. Shear allows loads to be transferred between structural members. Torsional loads occur when structures are twisted. Wing boxes twist due to lift acting away from the shear center. Fuselage and empennage experience torsion during asymmetric flight and yaw. Load paths change depending on what the aircraft is doing. In flight, aerodynamic loads dominate. Wings carry lift-induced bending and torsion. Tail surfaces carry stabilizing loads. Maneuvering and turbulence. Inertial loads appear due to aircraft mass reacting to acceleration, G loads. Engines, fuel, passengers, and cargo all contribute to inertial forces. On the ground loads dominate during landing, taxi, braking, and turns. Loads enter through the landing gear, not the wings. These loads are transmitted into fuselage frames and wing center sections. At cruise altitude, pressurization loads act continuously on the fuselage, create hoop stress and longitudinal stress in the skin and frames. These cyclic loads are a major driver of fatigue damage. Understanding load paths is fundamental to good aircraft structural design. Designers must ensure that every load has a clear, continuous, and efficient path through the structure, from where it is applied to where it is safely reacted. Poorly defined load paths lead to stress concentrations, unnecessary weight, and unpredictable behavior under real operating conditions. By designing with load paths in mind, engineers can place material only where it is needed, achieve redundancy and load sharing, and create structures that are both strong and damage tolerant. Modern aircraft structures are designed to withstand multiple load types, often acting together. Aerodynamic loads, lift, drag, moments. Inertial loads, maneuvers, turbulence, acceleration. Ground loads, landing impact, braking, crosswinds. Pressurization loads, cyclic cabin pressure. Thermal loads, temperature expansion and contraction. Emergency and abnormal loads, engine failure, bird strike, rejected takeoff, decompression.